Okay, so there we go. 6.4, we're graphing them now. Graphs of sine, and just sine and cosine. That's all we're going to do. We're not going to graph the other 4 trig functions. They're not used as much in calculus. Just mainly want to know the sine and the cosine really well. Okay, so for what numbers is the graph of that increasing? So where is the graph increasing? What does it mean for a graph to be increasing? Well, imagine if you're on a roller coaster. What if you're right here on the roller coaster and you're cruising this away, going to the right? So in what parts of the roller coaster are you increasing? Which means going up, right? So I go through here, that's going down, going down, going down, going down right here. So this is all down stuff. So from right here to right here, you're going up, aren't you? In this section, you're going up, and that's the only section. Wouldn't you agree? That's the part of the graph in which you're climbing, going up. So that's from where to where? From negative pi over 2 to positive pi over 2 on the x-axis. They're asking on the x. See the x? So it's from negative pi over 2 to positive pi over 2. Makes sense? From here to here on the x-axis. All right. So when does the sine of x equal 1? When is the sine of x 1? Can you tell? For what x value is the sine of x equal to 1? Remember, this you put in an x, you get out a y. Like any function. Plug in an x, get out a y. So they're saying, where's y1? Right there. This point right here, huh? This is over pi over 2, up 1. So x was pi over 2. Next question. Is that good? At x equals pi over 2, the sine is at a height of 1. They're just starting us off with some observations of the sine graph. Does that make sense there? At pi over 2, he's at a height of 1. Okay, so y equals 7 cos of x. Let me give you just a formula for that. Oh, first off, this number here, the absolute value of that number is amplitude. Amplitude is just how far above and below the baseline the graph goes. So it's absolute value 7, 7. So the amplitude is 7, meaning if that's negative, we still say the amplitude is positive. It's kind of like distance, right? We don't say, I'm going down to LA, so I'm going negative 400 miles. We just say positive answers for distance. Same thing for amplitude. We only give a positive answer, even if there's a negative in the front. It's just the amount. So that's the amplitude. Second question is going to be the period. It's 2 pi over b. Now, what do I mean by b? When you have a trig function, I call, well, yeah, let me write that out here. 7 cosine x. I call, or pretty much everybody calls, whatever's in the front a for amplitude, and whatever's next to cosine, what's next to cosine? There's just a 1 here. That's b. So b is the number in front of the x, multiplying the x in your trig function, your sine, cosine, tangent, whatever. Well, I guess we're just doing sine and cosine in this section. So b, so it's just like Pythagorean theorem or something. You know, it's a, b, or like the quadratic formula, ABC. So the b is the 1. So the period is 2 pi over b. You want to put this on your 3x5 card for sure for the test in a week. Period is 2 pi over b, 2 pi over 1. The period is just 2 pi. So the period for this cosine function is the normal period, 2 pi, because they didn't really mess with the x. They just left a 1 there. But if you mess with the x, you can alter the period, the cycle. So that one just has the normal cycle, because they didn't mess with the x. Good so far? Remember that? Okay, so y equals 9 sine pi x. So first off, what's the amplitude? 9 right here. Amplitude is 9. And what's the period? Let me give you a second. It's 2 pi over b. That's the formula for period. So it's going to be 2 pi over, what's the b? Yeah, the a is 9, the b is the pi, huh? So 2 pi over that, boom, cancel, period's just plain 2. Not 2 pi, but plain 2. Everybody good? Period's 2 pi over b, and b is pi. So the pi's cancel. Okay, so y is 4/5 cosine a 2 pi over 5x. So amplitude and period. This is A, this is B, right? So the amplitude is 4/5, period, 2 pi over B, 2 pi over negative 2 pi over 5. Good so far? 2 pi over B. Now grab this fraction, flip it up. As you know, 2 pi times 5 over negative 2 pi, right? Flip it upside down. Put this over 1. 2 pi's cancel. What do we got left? Negative 5. Because 5 over 1, and there's a negative. So negative 5. Easy enough? That okay? Amplitude period. We have learned to graph a ton of things in this class, haven't we? That's one of the great values. I'm hoping you find value in being able to crank out all these graphs. All that we've learned about flipping them and turning them and all that kind of stuff. I had a gal, was the start of this semester or last, that sent me a note that she was in calculus and all that she'd learned about graphing and pre-calc was helping her out. I hope that is your experience as well. So that's why we learned all these graphs. So last graphs we're going to learn is sine and cosine here. So how do you do that? Well, let me give you a technique to make it as easy as it possibly can be. Here's what I think is the easiest way to graph sine and cosine. I'm going to, first off, find the amplitude and the period. So let me write it up here. 3 sine 1/4 x, okay? And you know this is the amplitude, 3. The b is 1/4, so let's find the period. The period is 2 pi over b, so 2 pi over 1/4. Like that, so far so good, right? Finding the period here. Grab that 1/4 and flip it up there. So 2 pi times 4 over 1, that's 8 pi. We good so far? So the period is 8 pi. Okay. Now, how do we go about graphing it? Well, you want to know for sine and cosine the basic sine graph and then adjust it for the amplitude and the period. What is the basic? And that's how we've done all our graphs in this class. Have you noticed? I said, hey, just memorize or put in your 3x5 card the basic graph and then shift them or whatever as you need. So what's the basic sine graph look like? Where does sine start? Right at 0. He goes up, down, and back by 2 pi. The basic one does. That's the basic sine graph. So you want to know, first off, the basic sine. That's one cycle. That's one cycle of the basic sine graph. And after that, he just repeats, doesn't he? He just goes up and down again, right? If you kept going, he just goes up and down again, up and down again, up and down again. He just keeps doing that over and over and over again. He keeps repeating. And same thing to the left. He just keeps repeating his cycle, doesn't he? To the left and to the right, he just keeps repeating his cycle. So this is one cycle of the basic sine graph between 0 and 2 pi. Again, be real clear. He goes up to his maximum. And what's his normal maximum? The basic, just 1, and just goes down to -1. Yeah, let me put that on there as well. The normal basic sine without any adjustments starts at 0, goes up to 1, back down to 0, hits 0 in the middle again, and then down to -1, and then back to 0 again. That's the normal, unadjusted sine graph. Okay, now, what you do is you just adjust for amplitude and period. Let's start with the period. That's the most important part. Instead of going from 0 to 2 pi, one cycle, our period's 8 pi, we just calculated. So he's going to go from 0 to 8 pi. He's going to do the same thing. Only one cycle in that whole time, right? That's the period. That's one cycle. So that means halfway through, he's going to hit 0. That must be at 4 pi because that's halfway to 8 pi, right? And in between, he's going to go up and down and back up. Mine doesn't look too good, but you get the idea, right? And last thing, how high is that up and how far down is that depth? Well, the amplitude is 3. So it's going to go up to 3, down to -3. And there we go. There's one cycle. All we need is one cycle. Once you have one cycle, you can repeat all the rest. Does that make sense? I kind of box it, don't I? I just say, hey, just put one cycle in a box, 0 to 8 pi, -3 to +3. And that's it. And so now you can tell which answer is right. Which one does one cycle by 8 pi? Yeah, isn't it this right here? So it starts at 0, hits 4 pi halfway through, ends here at 8 pi. The other ones do weird things. Like this one doesn't start at 0. D doesn't start at 0. C starts at 0 but goes down first. That's not right. A doesn't even start at 0, starts down. So B it is. Is that okay? Questions? So y equals -3 sine 1/4 x. Now, what is that negative? The rest is the same. The only difference is that negative in the front. What does that negative in the front do?
Go down first.
Yep. Negative in the front. Graph goes down first instead of up first. So when we go to draw the graph here, it's going to be 0 to 8 pi. Because, if you did the period, it's the same as the last one. It's going to come out 8 pi. Halfway through is 4 pi. All that's the same. It's going to go up to a height of 3, down to a depth of -3. All that, the box is the same. 0 to 8 pi, -3 to +3. But instead of going up first, see how the last one went up first? Up to its maximum first. This one's going to it's going to start at 0. But go down first, and then back, and then up, and like that. It's going to do that. This one goes down first. So which answer is that? Isn't it A? Starts at 0, hits 4 pi, back to 8 pi, goes down first. Now, what's with like B, which see how B is kind of like, he doesn't even, he starts way over here. And C, or D, is way over here. Those are cosine graphs. Those are shifted because they're cosine, which we're going to get to in just a minute. So they're not sine. They're not our answer. Everybody good to there so far? Okay. So negative cosine 1/4 x. So -6 cosine 1/4 x. Okay, so first off, that's the amplitude. That means it's going to go from -6 to +6. All the graphs do. -6 +6, -6 +6, -6 +6, -6 +6. So that's just obvious. All right, so that's the amplitude. Now, what's the period for this thing? Let's find the period. Period is always 2 pi over b. That's for sine and cosine, exactly the same formula. No difference. This is my b right here, this 1/4, right? So that's going to be 2 pi over 1/4. Grab that, flip it up. 2 pi times 4 over 1, 8 pi. 8 pi is the period. Okay, so 8 pi is the period. So that means between 0 and 8 pi, cosine is going to do his thing. And the vertical is going to go from -6 to +6. We good so far? I've got the box, so to speak. The box is going to be just like this. From 0 to 8 pi, -6 to +6. So first off, well, wait a minute, actually, let me be a little careful. Hold on. Well, I'll get to that in a minute. Let's don't even look at those options right now. They'll throw you off. I wouldn't look too close at those right now. Let's just stay with our own box. -6 to +6, 0 to 8 pi is one cycle. One cycle. That's the trick. They're doing more than one cycle in some of these. Okay, good so far. Now, what does cosine do in his box that's a little different than sine? Let me go over here and show you. So the basic sine graph starts at 0, goes high, goes low, back to 0. Right, hit 0 like that. The basic cosine graph, what does the basic cosine graph do? He starts high. He doesn't start at 0. Goes down, goes back up, and finishes high between 0 and 2 pi, like this one does between 0 and 2 pi also. And, negative 1, the positive 1. Negative 1, the positive 1. Yeah, see the difference? The only difference between cosine and sine is sine starts at 0, the origin. Cosine starts high. He starts at his maximum and does kind of a U. That's the only difference. The only difference between sine and cosine is a shift. You can tell if you took that cosine and just shifted it to the right a little bit, it would be sine. In fact, they are. Cosine and sine are the same thing except for a shift. In fact, I don't know if you know this from trig, why is it called cosine? Like, why don't we just have sine and some totally other word? Why is it the same word with a co in the front? Why is there sine and cosine, tangent and cotangent, secant and cosecant? It's like pilot and co-pilot. Why do we have the co? What's the co stand for? I would have had no idea after trigonometry. Somebody asked me that. So I'm assuming you're where I was. It means complement. Now, what does complement mean? 90-degree total. Remember complementary angles from geometry? Maybe you don't remember. Add up to be 90 degrees. So that means that these two functions are the same thing. They're just shifted 90 degrees. That's what they're saying. Cosine is sine shifted 90 degrees. Anyway, you don't got to know all that. You don't got to do anything with that. Don't worry. That was extra. No extra charge for that. We don't. There's no questions on that. So anyway, that's what they are. They're just a shift of each other. They're the same function. Also, the only difference then between sine and cosine is cosine starts high instead of starting at the origin. Okay, back to the question then. So what am I going to do for cosine? I'm going to start high. And I'm going to go down, bottom, and back up. At least I would have. That's all wrong. Except for what? What does a negative amplitude always do to any graph? And what is a negative? That's a y effector, huh? But we've learned from the effector days, that's a y. It's not in there with x. It's not in here with x. It's a y effector. What does a negative y effector do to any graph? Flips it. Negative multiplied and the y flips it. So the whole graph, sine, cosine, whatever, they go upside down. So instead of starting high like the normal cosine does, it'll start low. It'll do an upside down U shape, won't it? It's going to look like that. We good? It'll start low and finish low one cycle. So which of those, now we're ready to look at the multiple choice graphs. Which one of those starts low first off? He starts low. He starts high. No way. He starts high. No way. He starts low. So far, it's either A or D. You with me? I'm down to either A or D. This one finishes by pi. No way. No way. Now, is A really right? Yeah, they went to 16 pi. What they did is they did 2 full cycles. So in other words, 8 pi is halfway there. 8 pi is right here. Here's 8 pi, right? Which is exactly what we have, upside down U from 0 to 8 pi. They just did it twice. They just did 2 cycles. That's right. Make sense? But that's also why it would kind of throw you off if you looked at it too early, because sometimes they do 2 cycles or a cycle and a half, or they do something weird. So probably just get yours right first, 1 cycle, and then look at theirs would be easier options. All right, try that one. Y equals 6 cosine. They want, find the following, show at least 2 cycles, use the graph. All right, so see if you can figure out which of those is right. First off, go ahead and graph 6 cosine and pick the right graph. Boy, that's actually very easy, huh? Can you see right away? So cosine, what is cosine? This is positive. So cosine is going to start, instead of starting at the origin, cosine always starts high, does his U thing, finishes high. Starts high, finishes high. Right? Starts high, finishes high. So which of those starts high, finishes high? This one starts low. I mean on the y-axis. This one starts low on the y-axis. No way. This one starts high, finishes high. by 2 pi. And this one does have a normal period. This is just 1, so the period 2 pi over 1 is just 2 pi. So that's right. So it's clearly A. That part's easy. What are there other? So yeah, what's the so now they want the domain and the range. I said it right here. I didn't read it. So what's the domain of the trig function? Remember domain?
Yeah.
But how far do they want? Oh, they just want the whole thing? Okay. Yeah, right. Domain is left edge, right edge. Domain is negative infinity to positive infinity, isn't it? It goes left forever and right forever. The cosine goes on and on forever, left and right. What's the range? That's the vertical coverage. That's 6 here, means it goes up to 6, down to negative 6. The range is negative 6. Oh, brackets, huh? Because it hits those straight on. So we need to put brackets. Remember, the brackets mean you're straight on those points. Negative 6 to positive 6 for the range. It hits the 6 right on, hits the negative 6 depth right on. Easy questions. All right. Okay. So y equals sine 2x. So can you just grab it right? I'm not going to do anything. Could it be A, for example? Look at A. Could it be A? We're talking sine. What's the basic sine? Where does sine start? Origin, 0. Right? Cosine starts high or low if it's negative in the front. Sine starts at the origin. So it can't be A. A's starting down here in the bottom. No way. Could it be B? Starting down here? No way. It's got to be C, which starts at the origin. It's got to be C. So that was easy. And then what's the domain? Domain for sine and cosine is always negative infinity to positive infinity. They always go left and right forever. So that's easy. And then what's the range? It goes from negative 1 to positive 1, because the amplitude's just 1 in the front here, huh? So negative 1 to positive 1 is the range. Good? Easy? So, okay, cosine y equals 4 cosine 1/4 x. So well, it's a simple question again. They're being so obvious. Can you just tell it's by law? I'm not going to do anything. Just which one is it? Just look at the starting point. How does cosine start? Does cosine start at the origin? Never. Cosine never starts at the origin. Cosine starts high if he's positive in the front, low if he's negative in the front. Which one of those is clearly the right cosine graph? A. B and C start at the origin. No way. They're being very obvious on these, aren't they? B and C start at the origin. No way. It's got to be A. Because it starts high. Right? So it's clearly A. It starts high. And domain and range are easy. How are we doing? No, I guess we're about at time, aren't we? All right.